our friend. I like to call our friend, our colleague, Pak Imam Safganti from Politeknik Negeri Jakarta, Indonesia, and his colleague. Topic is comparing online destination image of Southeast Asia, MICE destination projected through the website of the Convention and Visitor Bureau. You have 20 minutes for your presentation. Pak Imam Safganti, the floor is yours.
Thank you, moderator. Can you hear my voice clearly?
Yes, clear.
Okay, thank you. With your permission, I would like to share my presentation. It's okay? Okay, this is my presentation, and good afternoon, everyone. First of all, I would like to introduce myself. My name is Imam Safganti, and today I will present my papers, and this is actually the work of my team, our team in Politeknik Negeri Jakarta, and the paper itself entitled Comparing Online Destination Image of Southeast Asia MICE destinations projected through the website of the Convention and Visitors Bureau. And first of all, the background. In this section, there are three important aspects that I would like to highlight in this background. And the first is about the importance of online platform in MICE tourism marketing. For your information, MICE is an abbreviation of Meeting, Incentive, Convention, and Exhibitions. It is business tourism, actually. We have leisure tourism and also business tourism on the other side. And online platform plays a pivotal role in shaping the impressions of tourist destinations in today's digital landscape. And CVB, that is an abbreviation of Convention and Visitors Bureau. This is a destination marketing agency. They utilize their official website to swiftly, effectively, and affordably promote MICE destination and showcasing the key advantages. This agency normally tries to attract various international events to destinations. For example, Indonesia last year has been appointed as the host of the G20 meeting, and this year also conducted the chairmanship of Asian meeting. And within the context of MICE tourism, Convention and Visitors Bureau leverage various online platforms to effectively communicate with their target audiences. And one of the platforms is known as the official Convention and Visitors Bureau website. And then furthermore, we also would like to discuss about the significance of visualizing destination image. Well, actually, efforts to promote MICE destination through visual representation or through the official CVB website is crucial in attracting the interests of potential visitors. And previous researches indicate that potential visitors often form their first impression based on the visual images that presented on the official CVB or official tourism website. This visual-based web display, including photographs and video, are proven to be the powerful tools for enhancing the image of a destination and also influencing tourists' decision to visit. And the next, I would like to discuss about the research gap and the study purpose. Despite the powerful influence of visual characteristics in enhancing destination image through many other platforms, however, there is a lack of similar studies that particularly pay attention on the website of Convention and Visitors Bureau. Normally, they do this by using official tourism websites. But however, we try to doing something different by taking into account the official website of Convention and Visitors Bureau. Moreover, we also find that no prior research that has been conducted in the context of Southeast Asian MICE destinations that actually experience the world's highest growth rate of tourist visits. And we can say that this study aims to fill this research gap by contrasting destination image projected online through the website of CPBs in 3 major destinations in Southeast Asia. And then let's move on to the literature review. Well, in this section, we discussed about 3 different aspects. The first is we discussed about projected online destination image. This is actually image of destination that are projected through the various kind of online platforms like official website, social media, and also other platforms. And then we also discussed about MICE destination marketing. It's about how to market a MICE destination, how to attract international event to a particular destination. And then finally, we also address about the importance of Convention and Visitors Bureau in markets to destination. And then let's move on to the methodology. And the data collection process started by identifying the object of the research, which is the official Convention and Visitor Bureau website of Southeast Asia's major destination. And accordingly, we came up with 3 CPB destination websites, namely Indonesia, Malaysia, and Thailand. The destinations were selected because they represent destinations that share similar destination attributes in promoting the destination. Moreover, they also selected due to the highest number of tourists visit and in the region, according to the IEEE statistics. Moreover, the study utilized an image downloader, namely ImageEye. With the help of the application, this study can locate, view, and download every image on the website with the ease. So in total, we have 593 pictures collected and further analyzed. And the collection process was conducted from the beginning of June until the middle of June 2023. And since the current study seeks to analyze different image categories projected on the CPB website, the unit analysis of this study is limited only to photographs or images that display on the 3 CPB's website. And then we also conduct visual content analysis. In conducting this analysis, we adopt and reformulated and proposed 12 different image categories of analysis. The categorization was adapted and modified from several previous studies that investigated similar aspects of destination. And after that, each image from official CPB's website was further classified into one of the categories above. And here are the categories. As you can see, we have a table with 2 columns here. The first column in the left represents category of the image, and then the second column indicates the definition of the category. And then after that, we also conducted a correspondence analysis. Well, correspondence analysis actually a statistical techniques that creates a graphical representation or perceptual maps of cross tabulation or from contingency table that further converted into a perceptual. And here is the result of the contingency table. And then here is the result of the correspondence analysis. As you can see here, the results from the analysis in the table 5. We have a significant chi-square value of 267.925 that also express significant differences among the image categories projected through the CPB's website. Essentially, the findings imply that the 3 destinations projected online destination images that differ from one another. Additionally, it also displays the first two-dimension singular values. As you can see here, we have the second column in the table 5, which title singular value. We have the two score there. We have two values there. The first is 0.599 and the second is 0.379 respectively. Since the values were greater than 0.20, consequently a two-dimensional solution was deemed suitable for this analysis. Moreover, the table 6 also suggested that the two dimensions contribution in explaining the variance of 3 websites in the study reached 100% for all variances in this analysis. Therefore, there was no missing information when presenting the results of the analysis by using the two-dimensional solution. And then this is the result of the perceptual map that generated through the analysis, as illustrated in figure 1, where dimension 1 represents the CVB website and dimension 2 represents the content category. We have seen that the 3 CVBs reside on 3 different quadrants. Malaysia, Indonesia, and Thailand reside on 3 different quadrants of the perceptual map. It appears that INASEP, or the Indonesia website, is situated nearly to the 3 different categories, namely nature and country landscape, food and drinks, and heritage art building or objects. In comparison, MySEP, or Malaysian website, is located on the different side of the quadrant and is more closely associated only with one single category, namely festival, events, meeting, exhibition, and traditional clothing. And a similar situation also applied within the context of TSEP, or the Thailand website, where it also occupied other different quadrant in the perceptual map and to be closely associated with several categories, namely venue, accommodation, activities, and park, outdoor activity, sustainability, and people and way of life. And finally, this is our conclusion. The first, we have significant differences in the image projected by the 3 CVBs website, Indonesia, Malaysia, and Thailand. And this distinction indicate unique strategies employed by each destination in shaping and promoting their destination image to target audience. Thailand stands out with comprehensive visualization strategy, integrating MICE-related attributes with leisure-related attributes, and in contrast, Malaysia and Indonesia predominantly focus only on single aspect, and particularly that related with leisure tourism or leisure tourist activity. And here's some recommendation. The study suggests that Indonesia and Malaysia should enhance their visualization strategy by diversifying types of destination image presented on their website, and a more balanced representation of both leisure and business tourism attributes can attract a broader audience and contribute to a more holistic destination image. Moreover, the finding open avenues for further research in this field, encouraging exploration into the impact of diverse visualization strategies on tourist perception and decision-making. Finally, the future studies could delve deeper in the effectiveness of specific visualization approaches in shaping the overall appeal of MICE destinations. And I think that's all for my presentation. Thank you for the opportunity, and I will be happy if we can discuss several aspects of my talk. Thank you. Good afternoon.
Thank you, Pak Imam Safganti.
Yes.
So, ladies and gentlemen, attendants of this session, if you have a question to Pak Imam, please raise your hand so that I can give the time for you. I will wait. Is there any question? So if not, then I will ask the questions. Pak Imam, since in your presentation, and I think in the end of your presentation, you mentioned that the different image that try to project it by the website CVB of each country, it's different. And it gives me the impression that you consider the CVB of Thailand slightly higher into your perceptual map than the Indonesian and Malaysia because of balance position. That's what I understand. Is that correct?
Yeah, well, thank you for the question, moderator. Well, actually, the correspondence analysis is like correlations technique that apply for nominal data. And then further, we also compare the results with other countries. And in these results or in this finding, we can see that actually the three destinations resides on three different quadrants. It means that they project different image to their official website. And Thailand actually is more focused on their MICE aspect when promoting their image. So unlike Indonesia and Malaysia, Indonesia promotes their leisure aspect in addition to business aspect of MICE destination. While Thailand, this destination only focusing on one aspect, namely aspect that related with MICE business. In this context, as you can see in the perceptual map, actually Thailand more closely associated with one category, namely or with several categories, I mean, namely venue / accommodation, leisure activities, theme park, outdoor activities, sustainability, and people and way of life. So that's the different, I think.
Continue questions. So since you give some recommendation, so your recommendation to these two countries basically based on that their strategy, the country strategy should be aligned into your perception. And for Indonesia and Malaysia, you said it should be more balanced.
Yeah.
But in case of Thailand, you already mentioned it's more focused. So isn't any contradictory of this?
Oh, well, I think yes, Indonesia and Malaysia should balance their balance representation, both of leisure and business tourism, because normally in business tourism we also sell leisure aspect of tourism, because in a meeting like this, for example, after the meeting is finished, more participants could enjoy sightseeing or other tourist activities. So in MICE marketing or MICE destination marketing, we're not only sell the meeting itself, but we also sell the leisure aspect of the tourism. So probably this is the main reason why I suggest that Indonesia and Malaysia could make enhancement by conducting more balanced representation of both leisure and tourism strategy. That strategy that actually has been conducted by Thailand.
Okay, thank you, Pak Imam. There is one raised hand, Dr. Hira Makbul. Please give your questions.
I have just one question.
Yes, please, Dr. Hira.
So just want to ask, if adding Google images, like the images which have been uploaded by the tourists, will it gonna make any difference to your study, or will it gonna affect the results?
Yeah. Okay. Well, actually, I can hear you clearly. I cannot hear you clearly, but I will try to answer, because if I'm not mistaken, you were asked that if we add more images from Google,
yes,
could be the results, different results will appear or not. Okay. I think it's very possible we could have the different results if we add more images in our analysis. In our analysis or in our study, we only conduct research to the image that projected or presented on the Convention and Visitors Bureau website, and we use image downloader, image eye to collect the image and then further analyze them. And if we do that also by incorporating images from Google or by research by Googling, the images can be we will have a very large number of images that perhaps will change the analysis and also change the results of the analysis. That's
okay.
My answer.
Dr. Imam, we have only 1 minute left. Dr. David Cook, please, quick questions.
Thank you. I hope you can hear me fine.
Yes.
So in terms of the extension of this application of images, I wonder whether it's possible to include the multiplier effect of social media gained visual imaging, because if we have the multiplier effect, we capture visuals, but we also see how many times those visuals are repeated within a particular platform. And I think that might affect your research. Would that be of any application for you?
Yeah. Thank you for the question, Dr. David. Well, actually, in order to prevent that the same picture being analyzed twice in our study, we also conduct a check, namely like intercoder reliability. We check whether we prevent that one picture or same picture being analyzed twice. So we make sure that each picture only analyzed once. So moreover, if I'm not mistaken, if I understand you clearly, if we also incorporate social media in our analysis, the results also can be different, I think. That's my opinion. Thank you.
Thank you. Thank you, Pak Imam Safganti from Politeknik Negeri Jakarta, Indonesia, and his colleague, comparing online destination image of Southeast Asia MICE destination projected through the website of the Convention and Visitor Bureau. Please give applause to the presenter. Now we go to the second presentation. Second presentation will be given by Mylan Marabulas from University San Jose Recoletos, Philippines. The topic and colleague, and the topic is an AHP-based GIS method, hierarchy process method to detect biotic and abiotic stress factor of a cacao farm in Cebu, Philippines. So, as the presenter, who gives presenter?
Me, sir.
Okay, Miss June, Dr. June Anna Kalakat, you have 20 minutes for your presentation. Floor is yours.
Okay, thank you, sir. Can you hear me clearly?
Yes.
Okay. Is my screen already visible, sir?
Yes.
Okay. Good afternoon, everyone. My name is June Ann Kalatgad. This is actually a thesis of my students in collaboration with the Advanced Science and Technology Institute from the DOST Philippines. So this study is entitled HP-based GIS method in detecting biotic and abiotic stress factors affecting a cacao farm in the Philippines. So in our local dialect, we actually pronounce it as cacao rather than kikeo in a Western region. So from here on, I will be referring to it as cacao. So to start, here is the introduction. So cacao is cultivated in the cacao belt into 20 degrees north and south of the equator, and that is where the Philippines is also located. This makes the country suitable to grow cacao. Nonetheless, the country still imports cacao products and suffers low cacao yield. According to the Department of Agriculture and Department of Trade and Industry, the Philippines could not even supply its local grinding requirements of 40,000 metric tons. Despite its favorable geographic location, the Philippines' output for cacao production remains low, leaving the domestic and export markets to be undersupplied by the country. To be specific, the annual cacao production of the Cebu province, which is one of the provinces here in the Philippines, was only at 18.95 metric tons, which is less than the expected output from the province. This low volume of cacao production has been largely associated with environmental stress factors. The Philippine cacao practitioners deemed these stresses towards the country's impediment of low cacao volume and concerns and individual farms. The farmers in the country currently adopt the traditional method of ground survey in detecting these environmental stress factors. This method is a manual process of going into the farm to actually check the entire farmland of the presence of these stressors. However, this method is costly, time-consuming, labor-intensive, subjective, prone to human error, and efficient process because it is heavily affected by human constraints. Hence, there is a need for an advanced system to improve this current practice. So this study proposes the use of an HP or analytic hierarchy process-based GIS, Geographic Information System, to identify the spatial distribution of environmental stress factors of the case farm. HP will rank the stress factors before layering it on the ArcGIS software to produce the GIS maps. And the VI will then help track the site-specific condition of the cacao farm in terms of its vegetation. It will provide a visual presentation of the conditions of the cacao farm and will be classified as healthy, stress, and very stress conditions. So shown on the table are the 8 environmental stress factors identified in the study. So these stress factors are classified into 2, abiotic and biotic stress factors. So under abiotic stress factors, we have light intensity, relative humidity, temperature, rainfall, soil quality, flooding, and shade. And for biotic stress factor, we have insect pest and disease. The shape files for each of the stress factors were acquired from the various government sites and is summarized on the table as well. So the shape files will be embedded into the ArcGIS software for the GIS mapping. So for the case farm is actually one of the municipality here in Cebu province, which is in Tuburan. Tuburan overall has a cacao farm area of 64.58 hectares. For the specific case farm that is specifically located in Barangay Manga, Tuburan, which has 5 hectares and 10,000 cacao bearing trees. So the objectives of the study, number 1, is to identify the top environmental stress factors and environmentally stressed areas in the case farm here in the Philippines. Number 2, identify the current conditions of cacao beans and trees in line with the environmental stress factors. And lastly, provide policy implications from the results of the study to help manage the production of cacao. So to proceed with the results in the discussion, here is the result of the AHP ranking. There are 3 experts asked or surveyed in the study, and all experts are cacao practitioners for about 6 to 8 years. So unfortunately, from the 3 experts, only 1 expert passed the consistency ratio. The consistency ratio would attest the validity of the response of the expert. So succeeding processes are taken from the first expert's responses. So to proceed with the GIS mapping. So the GIS mapping results comprise the generation of the variable maps, each representing the environmental stress factors. And then the AHP integrated variable maps after all the GIS mapping, all the GIS maps, followed by the NDVI map. So I will just simply run through because each of these pertains to the 8 environmental stress factors. So the first map is the solar irradiance map, represented from the light intensity. So as shown on the figure, the farm receives a normal solar irradiance range. So again, I will just quickly run through them. So next factor is the relative humidity presented by the relative humidity map, also at a normal level. Next is the temperature represented by the temperature map, the same with the other 2 factors, still at normal level. The the rainfall represented by the rainfall map also at normal level. And then the soil quality represented by the soil organic carbon or SOC map. So as shown on the map, this indicates that most of the regions, specifically on the western part down to a large fraction towards the east, has a high buildup of SOC, which pertains to an improved agricultural yield. On the other hand, the eastern part of the map has low levels of SOC, which may result in low soil's capacity to supply nutrients for a long-term plant growth. So this might decrease soil quality level conducive for cacao trees. So moving on is the flooding represented by the flood map. So as seen on the figure, about 75% of the area is flood prone. Next is the shade represented by the shade map. So most of the trees receive about 3% shading, which indicates low shading. And the remaining part of the farm receives about 43%, which indicates moderate shading. So last factor would be the insect pests and diseases represented by the soil nitrogen content map. So the insect pests and diseases is presented on the figure. It is found that the entire case farm has high levels of soil nitrogen. This indicates that the farm is highly susceptible to various pest attacks and increase the probability of cacao plant diseases. So integrating all of those maps with the AHP result presented is the AHP GIS map. So on the right-hand side on the table presents the ranking of the 8 environmental stress factors. So as you can see, the top environmental stress factor is insect pests and diseases, followed by flood, soil quality, temperature, rainfall, light intensity, relative humidity, and shade. And on the left-hand side part of the slide is the integration of HP and the GIS map. So as seen on the figure, majority of the farm, the case farm, is susceptible to pests and diseases at the same time to flood. So identified are the top 5 environmental stress factors. So again, this was taken from the table on the previous slide. So we have insect pests and diseases, flooding, soil quality, temperature, and rainfall. So next is the INDIVI map. So the INDIVI map is to show the vegetated state of the farm. This map classify the areas of the farm into healthy, stressed, and very stressed conditions. So the majority of the areas in the cacao farm indicates healthy conditions. However, it can be seen that scattered areas around the farm are classified as stressed and very stressed conditions. So next is the segmented maps. The segmented maps of the HPGIS map and the INDIVI map are also presented to summarize the results of the top environmental stress factors and farm site-specific health conditions. Segments are zones 1, 2, 3, and 4 as presented on the slide. So upon analysis, it has been identified that the prominent stress factors in zone 1 are insect pests and diseases, flooding, and temperature. Zone 2 only has flooding. Zone 3, insect pests and diseases and flooding. And lastly, for zone 4, it has insect pests and diseases, soil quality, and temperature. So the results of the maps are validated through ground truth validation, which is observing the actual state of the farm. So I'll just simply run through the results, actual pictures taken from the farm. So this is from zone 1. This is from zone 2. Relatively, zone 1 has majority of the areas in zone 1 has healthy conditions. Zone 2, and then these are the factors identified under zone 2. Next is zone 3. So here are also the factors identified in zone 3. And then lastly in zone 4. And then here are also the factors which are flooding and the drying of the leaves. So each of these factors have negative implications towards the farm. So to summarize, there are 5. Number 1 is the rotting of the pods. Number 2, the damaged soil. Number 3, low productivity. Number 4, the yellowing of the leaves. And then number 5, the pod rotting, which is very prominent in the fall. So policy implications. The top 5 environmental stressors affecting the cacao farm have been identified, and these are, once again, insect pests and diseases, flood, soil quality, temperature, and rainfall. With a weight of 32.38%, the impact of insect pests and diseases is the most damaging, especially in zones 1, 3, and 4. Zones 1, 2, and 3 are the areas most vulnerable to flooding as well, since these are located near the river. Farm management should prioritize managing the effects of insect pests and diseases. Since soil quality directly affects the occurrence of insect pests and disease, the management may start tackling these two problems first. So in conclusion, the study employs AHP-based GIS to identify the main environmental stress factors impacting a case cacao farm. These results can serve as a valuable tool for a better cacao farm management. So that would be all. Thank you.
To Dr. June Ann Kalatkat for your presentation. So now I open the floor for questions. So for any attendant of this Zoom breakout that have a question, please raise your hand and then you can ask the question to presenter.
Sir, before we proceed with the question, I would like to correct, I have not taken yet my PhD, sir. So
Okay.
I'm not yet entitled with the doctor.
That's a wish. Any questions?
I am still about to take my PhD, sir.
Any questions? Okay, so I have question related to AHP-based GIS method. So basically, you employ the multi-criteria diseases analysis using AHP.
Yes,
But
sir.
AHP that you choose is actually only consistency ratio 1 out of 3. So you choose 3 sample, 3 expert. You do knowledge retention, and based on the 3, because only 1 who has consistency ratio, and it will be your initial. Okay. So
yes, sir.
So why you didn't choose all the 3 put into some discussion? Normally call group discussion, group factor, expert choice. That's my first question.
Okay. We have actually consulted with a lot of cacao practitioners, as well as representatives from the Department of Agriculture, as well as DTI in here, government offices here in the Philippines. But unfortunately, AHP is an iterative process. So only about 3 experts were able to answer the questionnaire. Also, along with that, we also have limited funds. So this was an undergraduate thesis study by my students. So I was there to supervise them, but unfortunately we have limited funds. It was not funded by the university or any government offices. So because of those limitations, we were only able to interview 3 experts.
I think one of my colleagues here raised also a question. What will your important factor of AHP weight?
Come again, sir?
The question that raised by my friend, what will be your important factor for AHP weight? So how you define the weight 32%, 25%?
Okay. So allow me to scan through my slide to go to the results for a while. So that was under results and discussion. Can you still see my slide, sir?
Yes.
Okay. So the results are actually taken from the answer of the experts. So they were the iterative process, which is the pairwise comparison matrix, was identified by the experts themselves. So as you can see here, the 32.38%, which was also reflected on the other slide, in the succeeding slide of my presentation. So from the AHP, it would result to weights. AHP is the hierarchy multi-criterion decision tool, and we could identify weights based from the responses of the experts. So the weights were taken from the responses of the experts. The weights were also taken in consideration before layering the GIS maps in the ArcGIS software. So I hope that answered the question.
Yeah, since we still have 3 minutes, so I will follow up the question. You have this priority rank in terms of percentage, but later you also have a percentage in terms of insect flood. So the variable, the rank, the variable percentage will result at the end of your presentation. You mentioned about insects number 1
yes,
for flood number 2.
Yes, sir.
Three or 4. Yeah. And this result because of the overlay, is it or what?
This was actually taken from the AHP result I presented on the previous slide, sir.
Oh, this is also a result from EHP.
Yes, sir. The weights will be used before overlaying the maps in ArcGIS software.
Okay.
So prior to overlaying, sir, we need to have the weights first, which was through AHP, and then the GIS, followed by the GIS.
Because it seems to me like is there the variable pest and insect pest disease has a good relation with the flood, has good relation with the rainfall. So the area or the location what's close to flood area will be have more pests and disease, and as a result we'll have this type of question.
So one of the things we have identified during the conduct of the study is that these variables are actually interrelated.
Yeah.
So one factor could actually result to another factor, could actually result to another factor. But unfortunately, that was not added into the study. So the point of the study is to only identify the classification, the health conditions of the cacao farms.
Okay. So yes. I remember in statistics it called like autocorrelation. Yes, but this is not the result of statistic. I agree. This is not result of us. Yes, this is result of your age. Oh, okay. Yes, thank you very much.
Thank you, sir. Thank you as well.
Dr. Candidate June Ann Kalakat and colleague.
Thank you, sir.
For your presentation. Thank you very much.
Thank you.
Please give applause to Ms. June Ann Kalakat.
Thank you.
Now we go for the presenter number 3 from Indonesia. Is preserving the hall, the East Hall of the Bandung Institute of Technology, and will be presented by historical significance HBIM implementation for the East Hall of Bandung Institute of Technology, Aula Timur. Okay, Aula Timur. The presenter will be Lia Christy Agustina and College. Presenter, we will give you 20 minutes for your presentation and floor is yours.
Excuse me, sir. I have a video representation for this session. Can play for the video.
So you going to make from your side because I don't have the video with me.
Okay.
Yeah, because otherwise I have to ask Pak Iqbal, the conference organizer. But if you have, then please from your side.
Okay. Let me prepare the video before. Okay, I can play the video. Here we go.
First, you have to stop Miss Lia Christy Agustina. Then when you share, you need to share and sound. So not only share, but it's also sound.
Okay, I'm stop share before share with Sunny.
Good day, everyone. A very warm welcome to
Is clear
CST,
the sound?
a conference where we delve
Okay.
into a realm where technology meets heritage, an intersection where the past finds resonance in the tools of the future. My name is Letristi, and my colleague is Mr. Agung Budiharto, Mr. Denis Wardi, Mr. Ketut Pikantingka, Mr. Iwan Purnama, and Mr. Marcelino Sandro Mardika, and we are from ITB. Today, I'm thrilled to share a story that combines our past with the cutting edge, the preservation of the East Hall at Bandung Institute of Technology using HBeam, historical building information modeling. Preservation of cultural heritage began to take shape in the field of archaeology in the Dutch East Indies in 1903. Back then, a growing recognition emerged regarding the importance of safeguarding historical artifacts and sites, laying the initial foundation for what would become a significant endeavor. Fast forward, in 1933, the government of the Dutch East Indies established legislation specifically focused on heritage preservation. This marked a crucial milestone, signifying an official commitment to protect and conserve cultural treasure within the region. The legacy of this early dedication endured through time, and then in 1992, this initial legislation became the primary basis for the formulation of the Republic of Indonesia Law number 5 concerning cultural heritage. This law solidified the nation's commitment to preserving and cherishing its cultural legacy. From this early beginning in the Dutch colonial era in Indonesia, reflect a nation unwavering dedication to honor its rich cultural tapestry. And then, over the years, Indonesia has made significant strides in the realm of the cultural heritage preservation, marked by enactment of various legislative acts and regulations. Among these milestones is the law number 11 of 2010 concerning cultural heritage. Building upon this foundation, the enactment of law number 23 of year 2014 on regional autonomy further reinforced Indonesia dedicated to cultural heritage management. This law empowered local government with greater authority and responsibility in managing their respective cultural heritage within the context of regional autonomy. ITB campus is one of cultural heritage sites in the city of Bandung with an area of 28 hectares. The ITB campus building, which was originally named Teknisi Hogeschool School Bandung, on Regional Regulation number 7 of 2018 concerning cultural heritage management in Bandung City, the ITB campus is recognized as one of the cultural heritage sites in Bandung. The S. Endo West Hall, Bandung Institute of Technology, formerly known as Barakebo B and Barakebo A, respectively. This building constitutes the initial structure erected on the ITB campus. The S Hall began to gain recognition in the 1980s when its function transitioned to the of a multipurpose hall. Structurally, but building stretched in length and showcased the distinctive traditional rooftop characteristic of West Javanese architecture reflecting the campus location. Henry Macklin Pond initiated the design process for this structure in the Netherlands in 1918. Upon its completion in 1919, Pond traveled to Indonesia carrying his design draft. Construction of the East and West Hall of the ITB commenced in 1919 and concluded in 1921 with notably slow construction pace potential due to the complex design intricacies. The primary structure of the building comprises laminated timbers form in a parabolic arch shape, adding to their architectural complexity. And the presence of ITB campus is not only signifies of a prominent institute of higher education, but also stands as a valuable heritage enriching the cultural identity of Bandung. Implementing this regional regulation underscores the importance of preserving history building like ITB campus, which holds historical, architectural, and cultural significance that should be conserved for the future generations. HBIM of Historical Building Information Modeling. HBIM constitutes a transformative framework within historical preservation, integrating advanced technology with heritage conservation practice. HBIM represents a paradigm shift by amalgamating building information modeling principle with the interests of preserving historical structure. This theory framework acknowledges the multi-phase challenge of the conserving heritage site, addressing accuracy, documentation, and holistic representation concern. HBIM crystallizes in its ability to amalgamate spatial and temporal data, offering a comprehensive digital rendition of the historical building. This theoretical framework underscores HBIM potential in revolutionizing historical preserving methodologies by amalgamating cutting-edge technology with nuanced complexity of the heritage conservation. And this historical BIM, where the BIM have a product data set and technical information, and we can another data is dimension and product geometry. When the two of this data union, it's be a BIM object, and the BIM process enabled to more efficient method to designing, deploying, and maintaining building assets through their life cycle. From initial concept building the demolition, in simple terms, BIM can be defined as process of digitally depicting all elements that make up a building, while technically it's defined as object-oriented parametric modeling, and information model is a digital model that consists of document, non-paragraphal information, and graphic information. This is methodology of HBIM implementation for ITB is whole A. In acquisition data, we have a semantic data and geometry data. In semantic data, we have a floor plan, historic document, information of restoration, and geometry data, we have UV lidar and terrestrial laser scanner. When this data have input to HBIM model with rainbow scan essential, with format less, and link through view with format.lgs, and then with tracing of these two model with SketchUp. After retracing and make a model 3D solid in this SketchUp, we can open this data from format.skp to the ArchiCAD for convert and transform to the BIM or to format.ifc. This is our data floor plan of east hall, and this is the roof for the east hall, and this is the change of restoration in year of 2014. In the door is have a change of material and another change in the column in interior. And this is how the looks of the change to the new form, but new form is just like the past. And for the acquisition on the geometry data, we have data from terrestrial laser scanner and data lidar. For the solid 3D, we have IFC properties. The image above is an example of IFC properties that facilitates semantic data related to the type of structure in building, namely column. Naturally, other elements also facilitate according to their types, such as door, windows, wall, roof, stairs, and other. Each element has specific information according to its object characteristic in the IFC property using ArchiCAD software. And this is IFC type hierarchy. In IFC properties before, the division of element is based on IFC data models, where the IFC type hierarchy indicates that each element is part of IFC building element, which is a derivative of IFC element. The development of the database with the primary entity being PIM element is associated with inform within database, ensure the object models have flexibility. And it is a comparison between the standing point of view of equipment at the resultant 3D model data for HBIM reveal that geometric information closely approximates reality. And this is the comparison of the real world and the result of scanning. And the summary tracked out the research in the four considerable obstacles were encountered, particularly in navigating the use of supportive software to facilitate the exchange of 3D models data. This challenge challenges encompass the diverse requirement for both geometry and semantic aspect within the realm of geometrics. The creation of 3D models, each rooted in specific disciplinary backgrounds by different drafters, lead to data production and varying format. Thank you for your attention, and I'm now open to any question you may have.
Okay, thank you, Ms. Lia Christy Agustina. Dear audience, if you have a question, please raise your hand. And if no question from the floor, I will ask you some questions. That is my duty as a moderator. Okay, so I will ask you some technical aspect of the study and practical implication. You mentioned your study highlight the use of the latest laser scanning technology or 3D mapping in the historical beam model. Could you discuss the specific technological challenge you face in integrating H-beam with this advanced scanning technique, particularly in capturing the intricate architectural detail of this hall, the Aula Timur, which is a historic building, and I've been visiting that place for years. Okay, that's my question.
Yeah, thank you. The challenge of mapping technology, it's for the cultural heritage preservation, it's so much challenging. If we need the model 3D for the H-beam, but the data for the mapping is an in point cloud, and we have to convert that point cloud to 3D model solid. But the problem is when the object is heritage cultural heritage, there have a uniqueness uniqueness object for the rooftop or the column is not it's so unique morph. It's a unique object. So I try to 3D model with automatic methodology, but automatic just for the regular object. So I can make or build the generate or solid data for the rooftop of its hall. So I generate the model 3D solid with manual tracing digitation in 3D. That's the challenge of makes the 3D solid for the heritage cultural in its hall. Maybe for the other building of cultural heritage, that the same thing we can found if we want to modeling the 3D solid. That's for the technically. And for the next for impact for this H-beam, the next research I want to know how the H-beam trend for now for the much building, the existing building or the planning for building can implement for the generate the zonation in site or area for management of site and area cultural heritage in Indonesia. Because in Indonesia, for technically, there's need to makes the procedural step for technically for this for this technology implementation. That's I think for the next research need to be more need to be more technology for implementation in other building or other object in cultural heritage in Indonesia. Excuse me, sir. You still mute?
More questions. You still
Okay.
have 4 minutes.
Okay.
My other question is on this model, the HB model, can be utilized as educational tools for students. In what way? For educational student or professional interested in heritage conservation and architectural history. But my question is probably focus on educational tool for students, since you are also a lecturer.
Okay. I think, yeah, that can implement for the student of user. But for this research, I want to another user is for the expert or decision makers of orientation, how this can how the cultural heritage can be using, or how can be to law of uh, law of the cultural heritage Indonesia for the zonasi, how the zonasi of cultural heritage in sites or the area of Indonesia. That's this the technically we can use this technology for the implementation technically of generate the zonation of area of cultural heritage in decision makers, I think.
Okay, thank you. Miss Lia Christy Agustina, thank you for excellent presentation. Thank you. Please
Thank
give
you.
applause to Miss Lia Christy Agustina. And the next presenter will be Dr. David Cook, Dr. Hira Makbul from Edith Cowan University. And the title of the presentation, Early Aesthetic Integration in Digital Twin Dashboard in Isolated Agriculture, Data Modeling, and Remote Networks. Dr. David Cook dan Dr. Hira Makbul, time is yours for 20
Hello.
minutes.
So I'm gonna play, so everyone can hear me clearly.
Yes.
Okay, so it's just gonna play the recorded presentation. If
I don't have in mind, so if you have, otherwise I will ask the committee.
okay, so I do have the one. So just
Okay.
gonna share. So just gonna play the presentation.
Hi, I'm Ramadu. I'm here to
So
give
can
a
you hear the
presentation
presentation?
on our article,
Clear,
which is
clear.
Static Integration in Digital Twin Dashboards in Isolated Agriculture, including data modeling and remote network. So welcome to the presentation. What I will cover in this presentation includes introduction and background to the need of digital twin dashboards, benefits from inclusion of aesthetics for these digital twin dashboards, and introduction to framework, which incorporates aesthetics for digital twins. There will be some examples of weak and strong dashboards, aesthetically weak and strong dashboards, and we're gonna see some case studies, AR, VR based case studies in agriculture, and the summary and the future work. So as we all know that agriculture plays a crucial role in global food security and sustainability. As the technology advanced, it continued to reshape various industries, and agriculture has not remained untouched. The form of information visualization is also being in demand for understanding of precision agricultural concepts. This can be beneficial as large volumes of data can be easily collected, filtered, and explored for relevant information using interactive visualization. So hectic tasks can be simplified using visualization tools in combination with tactile handheld devices or mobile phones and online technology sharing solutions. The term digital twinnings has emerged. This is an accurate descriptor and depiction from the real-time environment data and representing the data in a manner that enables the efficient use of resources just using handheld devices or mobile phones. The use of IoTs, drones, and machinery has been placed under global attention to meet the needs of the population that will going to increase up to 10 billion in 2050. The practice of digital twinning is well established in large and sophisticated agricultural establishments. But there is a wide-ranging and persistent response for the world to make use of the inexpensive benefits of the technology as part of the broad approach to the achievement of global needs. The benefits for the use of digital twins can be seen in terms of efficiencies and optimization of agricultural decision making. We are also making use of the AR and VR. So AR and VR, they have been around since 1950s, but this has been enhanced within the development of computer technology. Such real-time applications provide useful information in the form of virtually generated objects such as sounds, graphics, or text, through which people can interact to get real experiences through virtual contents. And in addition, it's possible to use these applications on handheld or mobile phone devices. So there is a reduction in supervisory cost for the livestock and crop farming. One factor that can affect the user experiences for such applications is aesthetics. So what does aesthetic means for such applications? So aesthetic refers to easy to understand and easy to interpret visualization of the data. So why it's important? Because aesthetics is the representational component of a broader range of sensory experiences such as interest, intrigue, positivity, and credibility. Applying appealing, easy to understand and easy to interpret and trustworthy aesthetics to certain objects changes their meaning and overall perception to the user. So aesthetics and functionality both need to be considered by the designers and developers of agricultural dashboards. Functionality is required for users' adaptation. Aesthetics that includes easy to understand and easy to interpret data required for users' positive perception. So this article actually explores the aesthetic AR and VR in agriculture and highlighting the impact on productivity and sustainability and the visual landscape of the farming. So what are the benefits of inclusion of aesthetics? So to be clear, aesthetic here means easy to understand and easy to interpret visualization of the data. So this can improve user experience and engagement, provide immersive experiences to the user by using combination of the virtual and real worlds. So when a user is surrounded by an immersive and aesthetically enhanced environment, the inclusion helps in elevating awareness and consequently elevates the user's presence and interaction with each application. Engagement is an important factor for such applications along with immersion. In addition, some retention and understanding can be enhanced with better immersion and with better visualization of systems developed for education and training. So we can also develop AR and VR based applications which can provide more immersive interactive learning experiences, and it is safe for training young students. So the concept of digital twinning is increasingly entering livestock farming strategies. This allows for developing technology and permits increase in the number of human population and ongoing trend towards urbanization. So in this article, there are also some case studies which are AR, VR based case studies has been discussed. So just to understand and highlight the importance of aesthetics inclusion. So there are case studies which include dynamic water consumption. So there are also dashboards which includes in the agriculture. So it is citrus yield. So drawback of this was that it was only developed for the citrus yield. Then we have the precision farming using AR and VR based applications, and we also have the crop monitoring using AR and VR. The framework, which is actually DADM framework, is used for increased immersion with dashboard and digital twin management. This encourages thoughtful visualization and careful structure for scenes. It also encourages the user-centered design principles, which are very important for any creating any appealing, which is easy to understand and easy to interpret handheld visualization of the data. So this is actually focuses on developing applications which are used for the handheld devices. So here are some examples of aesthetically weak dashboards. Here you can see that we can see some graphs and we can see some numeric data, which for any farmer will not gonna make any sense. So on the other hand, if we have a aesthetically strong dashboards, we can see that the words like poor, good, and the icons like the fire icons or the water droplet icons can have a more visual impact, especially when they are using the handheld devices, which is easy to interpret and visualize such kind of data. So summary and the future work includes that the aesthetics of AR and VR are reshaping the agricultural landscape, and therefore we need to develop such kind of applications which enrich the visual experience of farming practices. As technology continues to evolve, the harmonious fusion of digital and natural elements in agriculture will likely to inspire new generations of farmers, consumers, and stakeholders. The future work of this study will focus on specific areas of agricultural challenge and global concerns. This will also include the future for digital twin dashboards. Will going to apply the DADM model into detailed and specialized area where dashboards management by farmers requires uplift, technology acceptance and application, especially using handheld mobile phones or the handheld devices. Thank you so much for your time. If you have any questions, please do let me know. Thank you.
Thank you, Dr. Hira Makbul. Thank you.
Thank you.
We have 11 minutes, then I open the floor for questions. Then I will ask questions. In your presentation, you mentioned about the decision-making process that lead to effective deployment of digital twin in agriculture.
Yes,
and
that's right.
How do these factors vary across different agricultural contexts? Since you plan to do future research, what is different, or how do these factors vary across small-scale farm versus large-scale agricultural enterprise? I remember in one of your slides, one is the weak dashboard and another one is the strong dashboard. So in strong dashboard probably is easier for the small scale farms, but then more quantitative probably for large scale agriculture, but that's also, it can be contradictory. So what is your comment, especially in perspective of small scale and large scale agriculture?
Okay, so the concept here is to develop dashboards which are actually visually acceptable. So here visually acceptable means easy to understand and interpret. So it doesn't matter like scale of the farm, but it does matter how those results or sensory information or the information obtained from the sensors is represented to the farmers. So what we have experienced is farmers are not that educated. They don't understand the bar graphs or the line charts, which are given within the dashboards. So what they understand is is the visual information, like where will there going to be a high temperature, how much humidity would be there, like in terms of visual information. If you just look at the strong dashboards, you can see the very highlighted information there. Like it could be in terms of words, like easy to understand words like poor, good, or anything, or it can be in the form of icons like shapes, maybe as I have, if I'm just going to share the slide again, so if that's make a sense. So if you just look at these strong dashboards, so you can see that there is an icon there which is actually showing the moisture, which is a moisture detector, right? So it is in the form of a water droplet, so it's saying something there, water required. So simple explanation can like this can really help farmers. But if you just look at the weekly design dashboards, so here I think the temperature or the moisture line, the line given, the line given is in the form of a, sorry, the moisture given in the form of a line will not be understandable by the farmer. So this is what we want to do. We want to simplify the complex information, which is easy to understand by the farmers, especially the one who are not that educated, which usually rely on these dashboards to monitor their crops or monitor the climate and the weather conditions. So this is what our intention is basically.
Follow-up questions. Are there any specific design elements that have been found to significantly enhance decision-making capability of user? The specific design element, that's number one. And number two is that, is it different between if your user small scale farmer and the large enterprise farm?
So you're basically asking, is there any difference between the design of two different forms?
First, a specific design element, do they have different? Or it will be cross-board the same?
So focusing on the design elements, so that is what we have intention of doing in the future. We're gonna do the analysis based on different dashboards, and we're gonna compare those results, and we're gonna be kind of a user-based study in which we're gonna consider asking farmers which dashboards they think is more easy to understand and interpret. So this is one of the future works, future intentions, like to pick out the design elements which can be used for designing the dashboards. Secondly, you're asking about the scale of the dashboards.
Yeah.
So, sorry, scales of the farms, like, simple, small scale farms and the large scale farms. So it definitely depends upon the level of education the farmers are working there. So if they are like highly educated farmers, so obviously they can understand more complex dashboards. If they are like less educated farmers, then obviously we need to focus more on the visual representation of data than as compared to just graphs and lines. So I think Dr. David Cook will gonna highlight this as well.
Yes, please.
So, Bapak, I'm sorry, because both Hira and I wrote this together, I feel like I can add some additional information which helps to explain this. One of the changes in the way in which agricultural data is collected now is through the multiple deployment of IoT devices. So if we look at how IoT devices are put across the landscape, it doesn't have to be just farming. It could be any other enterprise. So it could be earthquake monitoring, it could be climate change or whatever. But in farming in particular, we have seen a rapid increase in the number of IoTs. What that has given us is a huge amount of numerical data, very simple numerical data. And this has changed the way in which people view different information. So whilst Hira was bringing out the point about the difference between Many farmers who, whether it's in Australia or perhaps in Indonesia, but certainly in Australia, the average farmer is not a well-educated person. So they do not understand complex numerical structures if they're statistically aligned. If they're put into simple bar graphs or very simple visualizations, then they can make generalizations and do something. But the other big difference which has changed now is that much of the farming landscape has a broad acre, a much wider conceptualization. And what this means is that different devices are used on systems which have low bandwidth. So they're not deployed on 5G or 4G mobile devices, but they're on much, much lower kinds of deployments. So 3G, in many of the cases on farming institutes, they're used on long-range, wide area networking, where it's only possible to have just simple numbers. So you might be talking about the amount of rainfall and you're just measuring it in a simple number, whether it's 20 millimeters or 25 millimeters, little things like that, as opposed to a much more complex way for a large scale. So you mentioned the difference between, what is the difference between large enterprises and small enterprises? Yes, there is an education element, but I think the most significant part also now is the bandwidth, the way in which the information is presented. So if we want a typical farmer to look at this information and to make optimizations, in other words, to look at this all the time, not once a day or once a week, but look at it on an hourly basis, they can make very important changes. If you take someone who's a farmer in, say, mangoes, who is trying to work out the perfect time to pick the mango crop so that it can go to market and can be sold for the most amount of money, those kinds of optimizations are the sorts of things that this new approach to dashboard management will change. It will mean farmers will make clever decisions based on visualizations that they can interpret rather than trying to be complex about it, as opposed to agricultural scientists who consider this is a just-in-time proposition. They need to be able to see, visualize, and act very quickly.
Follow up, Dr. David, questions I can ask to Dr. David. Since you mentioned about the low band. So meaning if you have the high band, probably it's different. Probably the aesthetic feature less important in the high band quality of network, is it? Is it that?
It is the big challenge, because all of our measurement devices are on IoTs, and so they're much easier to deploy in low bandwidth situations. That's the challenge. And currently there are scientists working everywhere to try and extract the most amount of information from low bandwidth situations. So the most obvious example of this is in the way that we use typical sensors. I'll give you one example, LiDAR sensors. So LiDAR sensors are used in modern cars to detect motion of objects. They're used in drones to detect collisions with a tree or a plant. And LiDAR sensors on farming enterprises allow us to use numerical data to then refashion that data into the shape of an animal, the shape of a crop, the shape of a particular kind of piece of produce, whether it's coffee plants, mangoes, any number of things. So the challenge is about using sophisticated measurements and somehow sending that information in low bandwidth situations and then recreating something which is visually so clever that people can make good decisions. That is the challenge, and that's what our research is based on.
Thank you. Thank you for your research. Dr. David Cook, Dr. Hira Makbul, for your presentation, excellent presentation and insightful. Thank you. Thank you. Give applause. And now we continue for the last questions, for the last presentation of this exciting session. The title is Mapping Urban Income Pattern via Geospatial Based Expert Opinion Technique in Selangor, Malaysia. The author was Abdul Rauf Abdul Salam, University Teknologi Mara Malaysia, Nur Aizam Aknan, and Zahara Muhammad Yusuf. And time is yours, 20 minutes, and it starts now. Thank you. No,
Can I share my slide?
Yes, yes.
Everyone can see the slide?
Yes.
Ladies and gentlemen?
Yes.
Okay.
Yes, Dr. Abdul Rauf, you can start.
Okay. Assalamualaikum and very good day, everyone. I'm Abdul Rauf Abdul Rassams. On behalf of my team members, especially my students, present a research topic entitled Mapping Urban Income Pattern via geospatial-based expert opinion technique in Selangor, Malaysia. We actually from the School of Geometric Science, Natural Resource, College of the Environment, UITM, Shah Alam, Selangor. So these our main points started from the introduction and ended with the conclusion. Ladies and gentlemen, introduction. Why income status is very important, especially for the Malaysia? Because we can talking about the income actually is reflect on the situation of the community of the people. We look at the figure, actually the map, most of the higher income of the community states located in the Peninsular Malaysia compared to Malaysia Sabah. Why? Okay. There's a many method to map it, but I believe that GIS and also mapping can be used for more better analysis and also for more better for prediction analysis and making decision making. So this is very important for our agency to predict and also to plan systematically for our society. Ladies and gentlemen, we're talking about the household income in Malaysia. Actually, it can be categorized into three categories. First, B40, M40, and T20. B40 meaning that below 40, M meaning middle, and T is top of first class. So basically, what the income actually for the B40? B40 actually is less than around 5,000 ringgit Malaysia or around 1,000 US dollar. So the people who's recorded a salary more than 2,000, we call is T20. But actually, how much monthly actually income do you want to need comfortably in Malaysia is based on the location. If you located in Kuala Lumpur, so more money used to comfortable in Malaysia rather than the another state. So the problem statement is about the low income. Low income actually, maybe there's no problem for the rural area, but actually even though your income is higher, but if you're staying or you're working in the highest urban area in Malaysia, so not wonder if you categorize as the urban poverty. So actually, even though we have a system, we call it online census system, but this system actually still have a weaknesses, especially in terms of the to get the reliable data and also the data. There's no updated base map, but this situation actually lead to the drawbacks or some limitation for the agency, for our agency to do something planning. So I believe that GIS have a potential to not only to display the map, but also to analyze the real situation of the urban poverty scenario in Malaysia. So what the study aim and objective, the study actually is to estimate the urban income, especially one the urban area, we call it Section 8, Kota Gunung Damansara, Selangor, by using GIS and also our remote sensing. So they have a three objective. First is to create the updated base map. Second is to create the database. Last but not least, to estimate the urban income status. And directly, we can predict what the current situation of this study area. So this study areas is located in Selangor. So Selangor actually is the most developed state in Malaysia, beside the Penang or also Kuala Lumpur. So we believe even though the area is very developed in urban, but believe me, there's some people that have low income. So research methodology, they have four stages applied in this study. Actually start from the preliminary study, okay, the preliminary study and followed by the data collection. So the data collection, they have a four main data set used in this study. We start from the remote sensing imagery that's come from IGES online, and then we also get the data from the local agency, average gross household, and we also need from the expert, yeah, the expert to know and identify the real value of the income population. And besides that, we also have the another spatial data, we call it attribute data, related with the building, housing, and others from the Google Map. For the third stage is data processing. Data processing actually is involved the base map. The base map actually we get from the digitizing picture GIS and also from the remote sensing, extraction remote pictures from remote sensing imagery from IGES online. And after this three process, so we get the result. The result is actually is parallel with the objective. So after completing the all objective, so we can produce the post result, which are updated base map, and then we have an updated database of urban building areas and also urban income status analysis and scenario of the study area. So the first result is updated base map of urban pictures topography. Why this updated pictures is very important? Because what? The previous map produced by the local agency actually is still the old outdated base map. So if using the outdated map of to analyze something, I think is a rubbish. Yeah. So the concept of the GIS actually garbage in is garbage out. That's why we need to update the database based on the multi-integrated method for the GIS remote sensing and also from the expert opinions. So another result is which is a second result is the database. This database is related with the urban building area and also estimated income. Okay. Uh, the last result is estimated urban income status poverty using GIS and also expert opinions. So based on the expert opinion and also the existing secondary data, so we can identify uh, uh, quali qualitative value of the income level. So the color the darker color is show the low income. So the light color show the high income. So looking at the secondary data, so most of the low income actually is located in apartment, people that located in the apartment and also flat. So the people who staying in the bungalows, Samidi recorded, yes, they have a high income. So based on the site visit that we conducted in the study area, so most of the area that recorded the locals of low income actually uh, is surrounded by low low uh, low residential area compared to high residential area. So, so after estimated predict the income, so we need to validate it first. How we validate? So they have two ways. First, based on the site visit, we go to the web CZ and also by interview the expert, the local expert for the Putrajaya Council department. Is it true? Is match is the result from the previous result is actually is consistent with the validation of what we have done in the study area. Okay, as I mentioned in the previous slide, most of the low income actually is located in the Southern Asia. So because this area actually, most of the area, the residential area is department, apartment, flat, and also condominium. Okay, so based on this, based on the map that produced actually, and we also did a site visit in the study area. So some fact of the urban poverty and the study area. First of all, this area actually has been saved, yes, impacted by the pandemic COVID-19. So the people in category B40 has been hit the hardest and with debts, jobless, loss and income. So this actually revealed that 30% of the M40 have now joined the P40, which is a low income. So we also identify that poor living condition, a government in action, exploitation of worker. So what we need to do actually, the government, especially the local agency, need to do something to help the people after the COVID-19. So this is a overall conclusion. First of all, yes, geospatial or GIS need combined with the expert opinion to estimate and also to export the real situation of the income status, especially in the urban area. Okay, for the recommendation, okay, we believe that this is very good tools because the combination geospatial and also expert opinion, to try to replace the manual or the existing method. However, we believe there's some consideration we need to do in this study area. First of all, add more information, especially for the facilities, services, and population data. And also, maybe we can do the advanced GIS regression analysis or artificial intelligence, machine learning to do something, a better result, or also the planning strategies. So that's all, ladies and gentlemen. Thank you for your kind attention.
Thank you, Dr. Abdul Rauf Abdul Salam. And I have opened the floor for questions. We still have 8 minutes. Then I will ask for the question. How you ensure the objectivity and the consistency of the expert? Because this is, in your presentation, social economic, it's very sensitive. Poverty area and classification is very sensitive. It's not only in Malaysia, I think also in Indonesia. This is subjective plus objective. How you ensure the objectivity and the consistency of the expert opinion?
Okay, thank you, Dr. Oni, for your question. It's very interesting. Yes, when talking about the social science, it's something it can be objective and subjective, but especially we identify whether our result is reflect the reality, right? Okay. First of all, if you based on the current situation, actually is take a time to update the income. So the best way actually, whether our local agency workers go every day or every week, but it's impossible, okay, because the manpower limitation and also cost budget constraint. So the best way is maybe we can combine with geospatial like artificial intelligence, remote sensing, and others. But there's still some limitations. So what we call is we need to combine digital and manual semi-automatic. So we call our method is more semi-automatic. So we try the base. First of all, in terms of the database, okay, database actually we based on the secondary data. Okay, but the secondary data still doesn't reflect the reality because it's outdated. Okay, what we need to update it. So see, this study actually is still the preliminary study, but we try the best to make sure our result is very conclusive and maybe accepted by the local agency. First, we need to update the database of the income, estimate income of the local and also database. Okay, next, we try to we try to discuss with the local person, but the only one, I think the only person that is very reliable person that can be verify the result is Mr. Sham. Mr. Sham is the one that head department of the social strategics in this Petaling Jaya consuls departments. So because he has experience more than 20 years, okay, that's the best way that we can do to make sure our result is consistent, our objective, and also the result is very consistent. But if you ask me about for the better result, actually there's many method. First of all, maybe after this we need to discuss with the more respondent, especially for the local community or residential area. That's all that we need. Dr. Oni, I can't hear you.
Okay.
Please off.
Is there any question from the floor? Otherwise, I will follow-up question. So, speed versus reliability. So in this case, is speed more important? That's what I understand. The quick result is more important than the reliability of data. Then
I would like I could share for this, because the study is still in the progressing actually. So first of all, what we need to do is how to update the data in the short time compared to existing method. Maybe the second time or the second stage is more the reliability of the data.
Okay. Okay. Dr. Abdul Rauf Abdul Rasam and Dr. Siti Normaisara Abdul Halim, thank you very much for your presentation, and we hope we can see your next presentation or your latest presentation. Please give applause to the last presenter for today, Pak Abdul Rauf Abdul Salam and Dr. Siti Normaisara Abdul Halim. And now,
thank you very much.
Yep. And now we came to the end of the presentation, but as proof that we have this meeting and this presentation, we need to have some group picture, and that we can send to the IEEE that we have this meeting. So for the audience, please open your video so that we can make a group picture. And the committee, please make a group picture. And I will count 1, 2, 3. 1, 2, 3. So, dear presenter, thanks, dear audience, thank you very much for your presentation and awesome presentation and discussion. I hope we can see you in the next presentation. Tomorrow is day 2 for AGERS 2023, and there will be some announcement. Also, if you still have some administration, house administration, please do that. And I hope that we can see the result of your conference or presiding and the next couple of months. And probably we can see you again in the next AGERS 2024. Ladies and gentlemen, thank you very much for your participation and have a nice, good day for today. Thank you very much.
Thank you, Pak On.
Thank you, Dr. Oni. Thank you, everyone.
Thank you, everybody.
Thank you, sir. Thank you, everyone.
Thank you, everyone.
Thank you, Professor Oni. Thank you.
Thank you, everyone.